Do subscribe to Smartron channel for free and press the bell icon to stay updated of our upcoming videos. Hello everyone, welcome to the channel Smartron. In today's video I'm going to talk about haloalkanes and haloarenes. But before starting this video, I would really like to thank each and every one of you who has watched our previous video on our channel and has subscribed to our channel. So thank you so much guys for showing so much of love and support, and stay along with us till the end and watch this video till the end, because we are on our journey to provide you the best content possible. So let's begin with haloalkanes and haloarenes. So first of all, before beginning with the main chapter, let me first introduce you with the applications of this chapter. What are the main applications of haloalkanes? So first, talking about the applications of haloalkanes. So some of the fully fluorinated compounds are present in our blood. They are the constituent of our blood. Then again, coming to another example, that is CHCl3. CHCl3 is used as anesthesia. Okay, now let me tell you about something about anesthesia. Anesthesia is such kind of a drug which is used by the doctors to faint a patient or partially make the part of the body numb so that he does not feel the pain in that part of the body. That's the use of anesthesia. So trichloromethane is used for anesthesia, which is a haloalkane. So moving on to our next application, iodine compounds are used to cure goiter. Now let me tell you something about goiter. Goiter is a hormonal disease which is caused due to the lack of proper hormones in our body, especially occurred in females. I am not going into the details of goiter, but let me tell you that goiter is a disease which causes swelling around the neck region, and to cure that disease, people used compounds containing iodine, and even doctors prescribe iodized salts to those patients to cure this disease, goiter. Now moving on to the next application, so that is triiodomethane, that is CHI3. So CHI3 is used as a disinfectant. It is also known as iodoform, that is triiodomethane. This is used as a disinfectant. So what is a disinfectant? Disinfectant is such a chemical which is used to kill bacteria. So as we have seen in a lot of advertisements on the TV, that the bacteria are all around us, in our hands, in the air. So to kill those bacteria before we are eating something, or maybe we are cleaning the floor, we use iodoform, which is used as disinfectant. A lot of people must have visited the hospital. In the hospitals we find a smell which is unique in the hospital, and we think that those smells are coming from the patient's medicines, but no, those smells are not from the medicines. Those smell are from these disinfectants, that is from iodoform. Okay, so now moving on to the next example or application. So chloroquine is another application of haloalkanes, which is a chlorine and carbon compound, which is an organic compound which is used to treat malaria. Okay, so those of you who don't know what malaria is a disease which is caused by mosquito bites, and that is a fatal disease. It can kill humans, and this chloroquine is used to treat malaria. So that's more or less all about the applications of this haloalkanes. There are a lot more applications, but I'm not going into the detail of those things. We will read them in the chapter Chemistry in Our Everyday Life. So let's keep this for that chapter only. This much of information is sufficient for starting this chapter. So now let me tell you the pattern how we will go in this chapter. First of all, we will read about the physical properties of this haloalkanes. Then we will move on to the preparation of haloalkanes. And at last, we will read the chemical properties of haloalkanes. So yes, that's all about this chapter. Haloalkanes, we will first read the physical properties, then the preparation of haloalkanes, and then move on to the chemical properties of haloalkanes. So right now we will be talking about the physical properties of haloalkanes. Okay, so moving on to the physical properties of haloalkanes. So first of all, point number 1, we have the hybridization of haloalkanes. So all the haloalkanes that we will see in this chapter or anywhere we will see haloalkanes, all of them will be sp3 hybridized. So let me write it down, sp3 hybridization. So sp3 hybridization, let me show it to you. So here we have the carbon, here we have the 3 bonds, and one is bonded with the X, that is the halogen. Okay, so as we can see, the hybridization here is sp3, but the overlapping here with the carbon atom is on the p shell. So here we will write that sp3 hybridized with p overlap. So that's the hybridization of haloalkanes. Now moving on to the next property, property number 2, we have the presence of dipole moment in haloalkanes. So comment down in the comment section, guys, that whether haloalkane is having dipole moment or not. Is it a polar compound or it is a non-polar compound? Come on, pause the video and go down and comment down below immediately and take a break, and I'll tell you whether it is yes or no. Okay, so I hope you guys have commented down below, and yes, you guys are right. Haloalkanes do have a dipole moment and the value of mu is not equal to 0. That means they have a dipole moment here. And the reason why it has a dipole moment is because the halogen present over here is highly electronegative. And due to the electronegativity of halogen, the attraction of the electrons is in this direction, for which we have a dipole moment, and the dipole moment is directed towards the halogen, and hence all the haloalkanes are also polar in nature. So the third point of the properties is haloalkanes are polar in nature. Okay, so now moving on to the fourth point. Now guys, tell me, looking at the structure of the haloalkanes, is there any possibility of hydrogen bonding? Is it possible that a haloalkane can go through hydrogen bonding? No, right? Because those of you who don't know about hydrogen bonding, let me tell you that hydrogen bonding is possible only and only if there is a presence of FON. That means if the compound has fluorine or oxygen or nitrogen, only and only if it has fluorine, oxygen and nitrogen, then there is a possibility of hydrogen bonding. But as we can see that in haloalkanes there are none of them, neither fluorine nor nitrogen, so hydrogen bonding is not possible. Okay, now you guys must be thinking that there is a presence of fluorine, because we are talking about halogens and fluorine is a halogen. Yes, you guys are right, but we will find fluorinated haloalkanes very rare, because the reason is of the size. The fluorine compound is so small that it rarely forms bonds with carbons. So most of the haloalkanes are not soluble in water, and the reason is because of this. Hydrogen bonding does not form in haloalkanes. But yes, haloalkanes are definitely soluble, but in organic solvents, not in water. So keep that in mind. Now moving on to the next point, that is point number 5. Yes, I was talking about the organic solvent. Haloalkanes are soluble in organic solvents. So guys, I hope you guys are noting down whatever I'm writing on the board. If you're not, then I would request you guys to note down each and everything, because you know, during the examination, 1 day or 2 days before the examination, it is very important for you to go through the notes and not go through the heavy books, because those heavy books will actually do what? They will distract you a lot, and it is practically not possible to cover 2-3 volumes of those books, especially before your NEET and AIIMS examination or JEE examinations, where you have to cover both the 11th and 12th syllabus. It is not possible to read so many books, but yes, you can definitely go through the notes which you have taken during classes and watching such YouTube videos or from your coaching centers. So do take down notes, guys. They won't take much of your time, and as you can see, I'm writing along with you, so write along with me and it will be super easy. So yeah, let's move on to the next point. Now let's talk about the boiling point of haloalkanes. So first of all, guys, tell me that boiling point depends on which factor? Come on, go straight into the comment section and comment down below that boiling point depends on which factor. Okay, so take a break, take your time and go and comment down below. I'm waiting. Yeah. Okay, now coming to the point, boiling point depends on van der Waals forces, and van der Waals force is directly proportional to the molecular mass. So more the molecular mass, more is the van der Waals force, and as the van der Waals force is more, the force of attraction between two atoms is more, so it is very difficult to break the bond between them. So eventually it is understood that any two atoms which have very strong van der Waals forces or which are bonded with strong van der Waals forces are very difficult to break. So they will definitely have higher boiling points. So I hope I am very clear with this point. So let me write it down to you guys. So point number 6, boiling point is dependent on van der Waals force. So I'm writing van der Waals force as VF. I hope that's okay. So VF is directly proportional to mm, that is molecular mass. So yes, this is the molecular mass. So according to molecular mass, the biggest atom here is iodine, then it is bromine, then it is chlorine, and then it is fluorine. So we can understand very well that the Ri will have the highest boiling point, the RBr will have the boiling point after that, then RCl, and the least boiling point will be of RF. So boiling point decreases this way and increases this way. So as the size of the atom increases or the molecular mass increases, the boiling point also increases with that. So I hope this point is very clear to you guys. It is very important to understand. The reason it is important for you guys to understand is that when the questions will come, you have to be very judgmental. It is not about how much you can mug up, but it is very important for you guys to understand and judge the questions in the competitive examinations, because you will get very less time. So you cannot actually mug up all the types of questions, but if your concept is very clear, you can crack and go through any kind of questions. So moving on to the next point, point number 6. In point number 6, we will be talking about the density, rho, density of haloalkane. Okay, now this is a very interesting topic and it is very important for you to understand this topic. So density of a haloalkane is directly proportional to the molecular mass mm of the halogen. So more the molecular mass of the halogen, more is the density. But here is a small twist. The twist is that the density of the haloalkane also depends on the molecular mass of the carbon chain, but that is inversely proportional to the density. That is, density of the haloalkane is inversely proportional to the molecular mass of carbon chain. So here we can understand that more the molecular mass of the carbon chain, less is the density. So let me tell you this taking an example. So in case of CH3I and CH3Br, as the molecular mass of iodine is greater than bromine, so definitely the density of iodine will be more than that of bromine. But here comes the twist. If we add up more number of carbons in the chain, let me take another example, example 2. If we have CH3CH2I and CH3I, so here the number of carbon atoms is more in this one and the number of carbon atoms is less in this one. So as we can see that the molecular mass here is greater than this one. So in respect to molecular mass, if we say that mm of this is greater than this. Am I correct? Yes. So this implies that the density of this is lesser than the density of this one. That means as the number of carbon atoms increases, or as the number of carbons increases in a chain, the density of the whole molecule gradually decreases. But on the other hand, if we have similar compounds with same number of carbon atoms, then the density will depend on the molecular mass of the halogen. So more the molecular mass of the halogen of compounds having same number of carbon atoms, the density will be more of that molecule which has more molecular mass of the halogen. I hope I am clear with this. If you have any doubt, do comment down below. I will definitely check it out and clear your doubt. So that's about the density. Now the final topic number 7. So topic number 7 is about the bond length. Okay, so as you all guys know that bond length depends on the size of the atom or size of the halogen. So more the size of the halogen atom, more is the bond length. So let me first write the order of size of the halogens. That is, fluorine is the smallest, then we have chlorine, then we have bromine, and then finally we have iodine. So this is the size. So as we can see that the bond length depends on the size and it is directly proportional to the size. So more the size of the halogen, more is the bond length. So here RF is the smallest bond length, RCl is after that, RBr is after that, and Ri is at the last. So this is all about the bond length. So the bond length increases in this order. Bond length increases in this order. Now the final topic of the properties, that is point number 8, which is the bond strength. The previous topic, the bond length and bond strength, are quite related because more is the bond length, less is the bond strength. So the atoms which are smaller in size, the haloalkanes, the halogens which are smaller in size, are strongly bonded with the carbon atom, and the atoms which are larger in size are weakly bonded with the carbon atom. So let me write down the order. So RF has the greatest bond strength, then is the RCl, and the RBr, and finally the RI. So that's all about the bond strength. I hope you can understand what bond strength is. So let me write it down, or let me tell you once again that how we are understanding which has more bond strength. So more is the size of the atom, less is the bond strength. The reason is the nucleus. Both the nucleus of the small nucleus of the both atoms are very far off because the size of the atom is big. But if the size is small, then the length becomes small. So that is the reason why fluorine has a greater bond strength, because the distance is very low and it is very difficult to break that small tiny bond. And in case of Ri, the distance is so big that it is very easy to break that bond, and hence the bond strength is very, very weak. So yes, that's all about this chapter, guys, about the properties. The next part, that is the preparation of haloalkanes, will be coming up in the next video. So thanks for watching this video, guys. Keep watching Smartron channel and do not forget to subscribe to our channel. If you want to get amazing questions on MCQs and practice more and more for your NEET and AIIMS examination, do not forget to follow our social media pages. That is @RonSmart007 is our Insta ID and Twitter ID, and every link will be given in the description box. So do go and follow our social media pages. And thanks for watching once again. Keep studying hard, keep working hard, and keep smiling, and do whatever you love to do. Do not be burdened with anything, and love you guys. I hope this video really helped you. Bye bye.